Hello, my name is Grant Kim, and this is my final lab report for this class for Physics 2212, lab report number 6. And now, I will introduce the lab. The objectives of this lab are to observe the differences between a real magnet and a simulated magnet by conducting an experiment. This experiment involves testing the difference in time that it takes for the magnet to fall through a roll of aluminum foil when dropped. The fundamentals for this experiment are the Biot-Savart law, Faraday's law, Ohm's law, the Lorentz force equation, and Newton's third law. A preview of the results shows us that the real magnet fell on an average of 0.891 seconds based on an average of 3 tests. Meanwhile, the simulated model, which was only tested once due to its existence in code, fell approximately in 0.311 seconds. And now, we will get into the experiments. The materials required for this lab report are a cardboard aluminum roll, a roll of aluminum foil, a bar magnet, as well as the glow script code provided for the simulated magnet model. The assumptions for this lab report are that air resistance is negligible, no other magnetic materials are nearby, the bar magnet can be treated as a magnetic dipole, and the uniform surface of the tube has no imperfections, bumps, cracks, or other imperfections that would alter the magnetic field. The objective of this experiment is to test the magnet's falling speed through the tube and compare it to the code model. The starting conditions are that the cardboard tube is wrapped in foil and the magnet is held above by us. The system of this experiment is the magnetometer, and the environment is the tube, the room, and everything else. The procedure of the experiment involves setting up the experiment as I just described, dropping the magnet down the tube, recording the amount of time it took to drop down the tube, and then repeating this procedure multiple times and taking the average in order to calculate the real magnet's falling time. Then, we can compare this to the simulated model, which only had to be run once. The expectations are that the real magnet would be identical to the simulated magnet. However, the real magnet was about double the calculated speed of the simulated magnet, or a little more actually. And now, we will get into the conclusion. The sources of error for this lab include imperfect measurements, possible outside conditions such as external magnetic fields, as well as some errors when handling the magnet and the other lab materials. And now for a few following questions. What if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? Well, the magnet would fall much slower due to the relationship between current and magnetic force. What if holes or slots were cut into the tube? How would this affect the ring currents in the model? If this were the case, the magnet would drop faster. The holes would create gaps in the surface area and decrease the magnetic force and induced current on the magnet. This concludes my lab report, and thank you for watching.